Dear students, in this video, I am going to discuss about comparison between Butterworth and Chebyshev filters. This is the frequency response curve, which means the magnitude response curve for analog low-pass Butterworth filter. This diagram is the magnitude response curve for the analog low-pass Chebyshev filter. Here I used to draw two diagrams, which is nothing but Chebyshev filter type 1 and this is a type 2 filter. So the first point in the comparison is the magnitude response, that is the h of j omega of a Butterworth filter decreases monotonically from here to here, decreases monotonically as frequency increases from 0 to infinity. So this is the frequency. The frequency increases 0 to infinity. The response curve is decreases. Whereas in Chebyshev filter, the magnitude response of Chebyshev filter exhibits ripples. So this representation is called as ripple, which means attenuations, distortions. It exhibits a ripple in a pass band or stop band. It's according to the type of the filter. If we consider the type 1 Chebyshev filter, the magnitude response of the Chebyshev filter exhibits ripples in the pass band range. If it is a type 2 filter, then the magnitude response of Chebyshev filter exhibits a ripple in the pass band. Okay, this is the first point. Second point is the transition band is more in Butterworth filter. So what is the transition band? So transition band is nothing but it's a band which allows the frequency between the pass band and the stop band. Which allow the frequency between pass band and stop band. So the gap between this portion is called as the transition band. So this transition band is more in Butterworth filter, whereas in Chebyshev filter the transition band is less. The next point is the poles of the Butterworth filter lie on a circle. Okay, the poles of the Butterworth filter lies on a circle. For finding the poles, formula is sk equal to e power j pi k, where pi k is pi by 2 plus 2k minus 1 by 2n into pi. In a Butterworth filter, order n equal to 2 means the number of poles obviously 2. So the two poles should be lie in a circle, anywhere in that circle. It may be the two pole is here to here or here to here. So anywhere, but it is in a circle. So the Butterworth filter poles or lies on a circle. Whereas in Chebyshev filter, the poles are lie on an ellipse. The same if n equal to 2 in a Chebyshev filter, order of the filter is 2. The two poles should be lie in a ellipse. In this direction, the pole should be lie. The finding the poles formula is sk equal to a cos pi k plus jp sin pi k, where pi k equal to the same form, pi by 2 plus 2k minus 1 by 2n into pi, right? Then for the same specifications, because both are analog filter, the specification is nothing but pass band ripple, stop band ripple, pass band frequency, stop band frequency. So this is the common specification for both analog and Butterworth and Chebyshev filter. So from these specifications, the Butterworth filter having a more number of poles, in Chebyshev filter having a less number of poles. Poles very higher means it's having a higher order filter, that is the n value should be high when compared to Chebyshev filter. Here less number of poles only produced, so it have a lower order filter. N is a very low number when compared to Butterworth. So n is higher means it requires a more hardware to construct a filter, right? In Chebyshev filter, it requires only less number of discrete component to construct a filter. So these are the basic comparison between the analog low pass Butterworth filter and Chebyshev filter, right?